Hey, hello, and welcome to the show. It's me, John Park, and we are doing show and tell with a guest host, me. We're going to have guests running the show for a few weeks while Phil and Lamore are busy moving boxes across New York City over to Brooklyn. And I think that'll take them a while. So probably through the end of the month, we'll have guest hosts here on the show and tell. And what I'd like to do is just jump in with some of our Adafruit makers and see what they're up to, and then also bring on members of the community. If you would like to show your stuff or tell your things, head on over to adafruit.it/discord. Look for the live broadcast chat channel. We have a link there that you can click and jump into our StreamYard, or just prep for it next week. We got a decently full slate, and we'll try to just spend a couple minutes per person and then give us a little time to get ready for the Ask John Parks workshop show that's happening at 8 Eastern time today. I'm going to take over that show for a few weeks as well. So I'll be in your face for a little while here. Hope you don't mind. Okay, first off, let's bring on Maker Melissa. Hey, Melissa.
Hi. So I have, you want to show my screen there?
Yeah, let's bring on.
So I have been working on the USB workflow for our CircuitPython code editor here, and I've gone through and revamped it. It was kind of being a little glitchy before, but now it is working much better. And it's also the changes I made allow it to connect to MicroPython here. So this is a MicroPython board that I have. It's a Pico that I have MicroPython 1.2 on, I believe. Mm-hmm. And so I can go ahead and do any of like the normal file operations that you would be able to do on the CircuitPython board. So it's working well for both types of boards now.
That's great. And so in this case, you've got options for wired over USB or Wi-Fi or Bluetooth, depending on the board. What are you using here in this case?
This is wired, yeah. And because MicroPython doesn't have like a CircuitPy drive, it actually makes things simpler since everything's gonna always or never be read-only. So it just kind of just does everything through the REPL, and so you can actually bring up the REPL, and it's hiding a lot of the operations that it's doing and just showing you if you want to enter something in here like 2 + 2 or whatever to show that it's 4.
That's great. Yeah, we're glad that
you list all the files and stuff, and it doesn't even show it here.
Oh, that's great. Yeah. Thank you. Thank you so much for that. I'm going to dive in a little more with the web workflow. I think I showed it once on a CircuitPython parsec, but I'd like to spend more time with it so I can.
Yeah, this is the USB workflow here, as opposed to the web workflow.
Right. No, that's great. And this is probably, I haven't heard from educators on this, but I'm guessing this is a potential solution for schools where you can't plug in, add IDEs and software, or even access your devices sometimes as a drive, because this kind of goes past all of that, right?
Exactly. It runs right in the browser. No installation necessary. No components to install. Nothing.
Really cool. Well, thanks for showing that, Melissa.
Well, thank you.
Is this something that is available now, or is this stuff that is coming soon?
It is available now. This is on code.circuitpython.org that I was demoing this off of.
Perfect. Thanks so much. We'll see you later.
Thank you.
Very cool. All right, next up, we got Scott. Hey, Scott.
Hey, John. Thanks for hosting and having me. I'm in the weeds, man, but let me tell you what weeds I'm in.
Good.
The Matter IoT homespec is this like new, supposed to work, just grand, dandy, be secure, blah, 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 all this stuff. Turns out it's complicated, and I signed up to re-implement it in Python, which is kind of a crazy idea. But I don't have to do absolutely everything, but there's a number of layers to the basics that I've been working on. So we're calling it CircuitMatter. It's thrown my fingers off a little bit to type circuit and then not Python, but I'm working on it. But if folks want to follow along, they can go to github.com/adafruit/CircuitMatter. And I just wanted to show that because I have all these layers I've got to build before I can have like a light turn on. I'm actually using testing to test the layers that I'm adding. So here is an example of message reception state being tested, and then TLV, which is the encoding for the packets itself, is being tested as well. And it's green. So I'm making progress. It's just there's a lot to do, but I'm making progress slow and steady. So if folks are excited about Matter, yeah, I'm excited that you're excited.
That's great. And are you you've been working on this some on your deep dive live streams? Yeah.
Yeah, I did it last Friday, and I'll be working on it again this Friday.
Great.
Maybe we'll send a packet this Friday. I don't know.
Okay.
We'll reply to the very first packet we get in.
Good luck. That's great.
Yeah, thank you.
Great. Thanks, Scott. See you.
Have a good one.
All right. And now, relatedly, bringing on Jepler.
Hi. So yeah, I've been working on another part of this little thing, which is support for IPv6 in CircuitPython, because this Matter protocol always goes over IPv6. And earlier today, I created a draft pull request. I've been working on an Adafruit Metro ESP32 S2, and stuff is starting to work. So you can connect to Wi-Fi, you can get IPv6 addresses. This one, I think, was the one assigned by my router to the device. And you can send a ping then to your to the router, which is acting as the DNS server, and you can resolve addresses. You can try pinging Google over IPv6, but it doesn't work because my ISP does not have IPv6 connectivity. So it's purely working inside of my house right now. But I happen to have a local NTP server. So I tested UDP packets by sending and receiving a packet on the NTP server, and also connected to a local HTTP server. So there's a really big list of stuff that's left to do, but I've been picking away at some of that. So now you can connect, or you can bind a server to IPv6 addresses, and that includes the CircuitPython web workflow itself. This ugly address up here, let me resize this, and maybe it'll get bigger. Anyway, this address up here is the IPv6 form of a URL.
Nifty.
It actually starts http:// and then this immense hex number all in brackets, but that just shows that I can even connect to web workflow over IPv6. And of course, that's because other people have created most of the groundwork for this. So this uses the LWIP IP or TCP IP library, and they support v4 and v6. So a lot of this is just making the things match up. And then once you start to do that, a lot of stuff starts working pretty well. So if you're interested, you can keep an eye on this pull request. It's number 9436. I'll be working on that for the next week and a half or so before I take a little vacation. But that's what I'm up to. And soon we will have IPv6 support in CircuitPython on Espressive microcontrollers.
Oh, very cool. And hey, we had a comment over in the YouTube chat from Mike P, who said, you can get a free IPv6 tunnel to test with wider IPv6 with wider IPv6 connectivity. So I don't know if
it's like he.net or something like that. I've dabbled with that. I've found that it is nice for a little bit of testing, but a lot of websites treat those addresses as like suspicious, because I think people also use it for nefarious stuff. So like I was trying to order stuff on, I used to have this just set up by default, and I was trying to order stuff on McMaster, and McMaster is like, we're not going to show you anything.
That's funny.
And so I turned it off because it doesn't actually help. But yeah, this commenter is right, and thanks for the comment, and I should go do that. But that's why I don't do it on the daily. But that's the one that I know of, and it worked really well, and I should do that for testing this stuff.
Very cool. All right. Thanks, Jeff.
Right. Thank you, John. See you around.
Right. So let's see. Next up, we've got some people from the community. Why don't bring on Chris if you're ready to go?
Yes,
Chris.
I am. So I wanted to show off a learning guide that I wrote that went live this week.
Excellent.
And,
put it up on the screen here.
Yeah, a few weeks ago, Adafruit released a new board called the TRRS Trinkey. And it's a little Trinkey board with a jack on it, a TRRS jack. And that stands for tip, ring, ring, sleeve. And it's a jack that was originally designed for using headphones and microphones all in one cable. But we use it in the assistive technology community to connect 3 assistive technology switches at once, 3 AT switches. And so what I did was I added, well, the board has a STEMMA QT connector, which is great because that lets me add other things to it completely solderless. And so I added a little OLED display. You can see in the upper left corner of the guide there. We have OLED display.
That looks great.
What we're doing is we're stimulating a mouse and a keyboard. And this screen I'm showing you here is the keyboard screen. And it, as you can see, I'm going to, wait a minute, the other version here. Yeah, this one. Implements a full keyboard, including a row of function keys and arrow keys in the bottom 2 rows. And what you do is you use 3 of these assistive technology switches to navigate your cursor around that screen. And then when you click select, it types that like it's emulating a USB keyboard.
That's great.
So you plug it into your laptop or your desktop or whatever device you want, and it emulates a keyboard. Then there's also 2 other screens that allow you, let me scroll down here. This is the mouse screen. You can see all those arrow keys are moving the mouse in different directions. The lowercase L in the center is left click. The little R on the right is right click. These uppercase letters are for holding or dragging the left, right, or middle mouse button. Okay? And then the third screen is some arrow keys, just up, right, down, left, keyboard arrows, home, end, page up, page down. And then this middle row here, those are some special commands. That's a Control Z, Control Y, Control X. Those are for undo and redo, cut and paste, different commands that you'd like to have a shortcut to. And so you can plug in your existing assistive technology switches, plug it into the Trinkey, plug it into your computer, and be able to basically do anything that you can do with a mouse and keyboard.
That's great. This is really
and it's
cool.
all solderless. And so the only problem is the screen is sort of small.
Yeah.
Because if you're shipping pixels over STEMMA QT, it takes a while. So you're not going to have a very high res screen. But if they ever come up with a larger screen with a STEMMA QT connector, we might upgrade this. But anyway, it's the guide is up now. There are 3 YouTube videos that show you how to use it, how to assemble it, how to set up everything. And it's also in this guide, there's something called switch control on touchscreen devices for iOS and some Android devices. And on the original Trinkey learning guide, Liz put up a CircuitPython and an Arduino switch control application. But I have a more advanced version. And in my advanced version, it allows you to simultaneously press 2 of your AT buttons to get more functionality out of it. And I showed how that works in the YouTube video. So anyway, I was really excited when the board came out. I immediately saw this application, and it was a lot of fun thing to put together.
That's
I think
great.
it's going to help a lot of disabled people.
Thank you so much for putting it together and putting the work into it. Yeah, I love the addition of the screen so that you can add pretty much unlimited amounts of customization.
Yeah, you could take that third screen and add more custom macro commands. And I've got some in there like an Alt tab to switch between windows, and a Windows left, Windows right to dock your windows. But you come up with any sort of Control Alt or Shift combinations.
Yeah.
And commands you use frequently, and put them in there yourself.
That's terrific. Well, thanks for doing the work and for documenting it and for coming on to talk about it, Chris.
My pleasure. It's good to be back.
Yeah, it's great to see you. Hope we see you again soon.
Yeah.
Bye-bye. All right. So let's see. Next up, we'll bring on Samson and Ezra. Hello.
Hey, how's it going? Yeah, very happy to be here. This is our first time on the show and tell, but my name's Samson. This is Ezra. We're students at USC. And over the past few months, we've been developing this guy here. We call it OpenMode, and it's an ESP32 based dev board that's a drop-in replacement for your Wii-style controller shell.
Ah, cool.
Yeah, you just drop it straight in. It has USB-C, and it's equipped with a whole bunch of features. So on top of being able to use the existing 12 buttons that you already have, it has a 6-axis IMU, Bluetooth and Wi-Fi, of course. You can use the OEM speaker and rumble motor, so you have sound and haptic feedback. It has spots for IR LEDs, both narrow and wide beam, so we can have that kind of TV be gone functionality, turn on TVs, projectors, radios, things like that. And because it's fully Arduino compatible and hopefully at some point CircuitPython compatible, you can basically map it to control whatever you want. So we have a demo here connected to my phone. Whoops. So I can, this way, use it as a media controller. So I can turn the volume up, down, pause, and skip. We also had it mapped to a computer with like a keyboard type functionality, so you can map it to basically anything. And we're really excited to see what everybody else does with it. I think the only thing I forgot to mention is that it also has battery charging. So you can put a LiPo where the AA's were previously gone. And so you can also, control these onboard LEDs however you want. On the final version, those might be RGB, depending if we switch to, I think it's a 5-volt architecture instead of 3.3.
Mm-hmm.
And we're live on Kickstarter right now. We might be shifting over to crowd supply because we think that might be a bit of a stronger community, but we really want to see what other people make with this.
Yeah, that's fantastic. Really cool. I've never seen a drop-in replacement on a Wiimote. That's really great. I have about 6 of them laying around, so I could sacrifice one to throw a new board in. That would be great. Do you have a site up where people can get info right now, or should they go to your Kickstarter and then follow you to crowd supply if that's what happens?
Sure. So the Kickstarter is the best option. So openmode.io will direct you straight there.
Yeah.
We also plan to open source everything once we get everything situated on GitHub. So all of the information will be there, and we're going to try to write a library also to make it super easy to write code for.
Yeah. And so what are some of the big target uses that you have in mind for having this type of open controller?
For sure. So a big one would be like smart home automation, things like that. Instead of having a bunch of different remotes, it's a very familiar form factor. People know how to use it. So, controlling your Spotify on your phone is one example, but we also had it rigged to work with an Apple TV, things like that, control Alexa, Google Home, those types of devices. And then also if you have any sort of ESP or really any Arduino project that you want to control, rather than having to build a custom controller, design that, make it a closure, route all those buttons, you can kind of repurpose the same controller for lots of different projects and just upload new code.
And you may have said this, connectivity is Bluetooth and infrared?
Bluetooth, infrared, and Wi-Fi.
And Wi-Fi, yeah. Sorry. And you were saying?
Yeah, so I was saying like one fun use case we found for it was using Bluetooth to connect it to a phone and then having it treat it as a Bluetooth keyboard. So we were using the accessibility settings to fully operate like a regular modern touch phone, but through a Wii remote, which we found to be really fun, but also like there was a lot larger of a capability that we could see down the road with that.
Yeah. This is such a cool project. Thank you guys so much for coming on. We'll be looking forward to your progress and come on back anytime to show and talk about it.
Of course. Thank you so much, John.
Thank you.
Thank you. Take care. All right. That was very cool. Next up, we've got Bolan Mitov.
Hello, everyone. Hello, John. Yeah, this time, last time I was working on a lot of Adafruit stuff, but this time I had to divert. So I bought recently this Key Studio. I hope I pronounce it correctly. Shield. So I can test my Visuino support for the PlayStation 2 controllers. And what I discovered was that I can significantly improve the support. So I will quickly show you how you can build a project. So first of all, I have mapped both the controller and the Guitar Hero controller. I looked at bit banging, but I ended up with using the SPI for the communication. And so in this case, let's say we connect to the SPI and we connect to the digital pin 10. And let's.
Do you have a screen that you're trying to share? Because I'm not seeing it.
Oh, I'm sorry. Oh,
No
crap. Yeah, I'm sorry. I'm kind of new to this, and I forgot that I have to select sharing screen.
No, no worries.
Yeah. Long day here. So let's see if the screen is coming. Yeah. Okay. Yeah. So basically, I will repeat the same from the beginning. It's fairly easy. Come on. And so, as I said, I have mapped both the PS2 controller and the Guitar. And I ended up using SPI interface to optimize it. I have found some documentation on that. So in this case, I'm starting new project, dropping the component and connecting the chip select or attention. As it is called, I should add attention here, but that's okay. And now, as example, I can monitor the Y of the left stick. Okay, selected left stick, connect it here, and let me connect the board, and we can program it, and we can see the project running. So all I need to do is select the right COM port and click here to compile and upload. So let's see if the project is going to work. I can set how to connect once the compile has finished, so we can monitor on the serial port. It's going to take a little bit of Arduino compiler. It's taking a bit of time. I mean, C++ compiler after all, but should be a few more seconds. Yep, and now it's uploading. Come on. Upload it already. Yeah, it's taking its time. Okay, it's uploading. Yeah. Okay. And now we should have serial communication. And the controller takes a bit of time to basically reset, but you can see that I can control now. Mm-hmm. And I went even further. I not only mapped it as a component, but I also mapped it as a shield. So if we go to the shields, yeah, so I have done my due diligence. Right here, this shield is mapped. So I can select the shield, add it. Immediately, we'll get everything added to the board, including this board has servos. So as example, I can connect X to control one of the servos and Y to control the other servo. And I know that time is limited, so I'm not gonna show it, but I tested it earlier. It worked perfectly fine. And of course, here in the object inspector, once it gets updated, right here in the shield, and I can disconnect not to each CPU. I can switch between the controller and the guitar. So yeah, again, you can do it through a shield, you can do it through component, any way you want it. And as part of that, I also updated this guy, which is a different type of shield. Both of them were properly updated in Visuino. And hopefully tomorrow we'll have a new beta version of Visuino that anybody can download and test. And in the next couple of days, it will be part of the official release together with everything else that I introduced for the Adafruit products. So that's what I have been working on since last week.
Excellent update. That's a lot. Thanks for showing it off.
I keep busy.
Yeah, good for you. That's great. Thank you so much. We'll see you soon.
Thank you.
All right. And last up, we've got todbot.
Oh,
I didn't warn you, did I? You didn't know you were the last one.
Hey, how you doing, John? So I have a couple things to show. I'm going to switch my camera so that I can show you them. As you know, I'm into the synthesizers.
Yeah.
And here's some. But what I want to show is this cool little KORG oscilloscope kit that you can get that's designed for audio applications. It's got like, 2 channels of stereo in and some throughs and some outs. It'll actually act as a function generator as well. And so I'm going to turn on a little CircuitPython program on this guy, and you'll be able to hear it, I hope. And so dual channel for this thing, but it's also got FFT mode, which is pretty neat. Not very useful, but I think it's pretty cool. But most important for me is this. I'm playing with how to do correct portamentos in CircuitPython, and so this thing has a nice, accurate tuner that also displays the waveform, and so I can see exactly. Oh, it's F1, then now it's C2, and like it's exactly on the money C2 with 0 cents, right? And so that's the main thing I wanted to show.
Neat.
The sort of secondary thing I wanted to show is I'm working on this is one of my little synth projects you can get on my Tindy store. And it's currently mostly for CircuitPython, but I've been working on an Arduino UI for it. And so like it's got, touch pads down here to play the notes, and then it's got some controls up here to let you edit the sound. And so the thing that I'm working on is this interface, this UI, where you got like a list of parameters, and then once you pick a parameter, like say what kind of waveform do you want, you can pick, sine wave, square wave, saw wave. What kind of filter do you want to pick? I want low pass, high pass, band pass. And it's really just a bunch of C++. It's nothing that interesting in terms of like because like this has been done before many times, but for me it's kind of cool.
But it's a lot of work to implement it. Yeah,
exactly, because it's Arduino and it's a little bit harder to do some of this stuff, compared to CircuitPython display IO.
Yeah. Oh, that's a cool, very cool update.
But anyway, that's all I got. Thanks for having me on.
Thanks, Todd. And since I made you say this before, but you had posted this image on your Mastodon, and I needed a background tonight because I have a blue screen set up. So my blue screen's going a little crazy there. But can you tell the good people what we're looking at?
So if you look at it, you notice it's like this concrete nook that's got phones in it, but it doesn't just have one phone. It's got kind of all the phones from throughout history. It's got like the 2-piece phone where you hold it to your mouth and your ear. It's got a rotary desktop phone, and then it's got a more modern rotary phone, and then in the bottom left it's got a touch tone phone, and then in the top right there's this unlabeled knife switch. And so where this is at the Hooker telescope at the Mount Wilson Observatory in Southern California. It's where Hubble discovered that the universe was expanding. It's why there's a Hubble telescope, is because he discovered this, and our thoughts about where we are in the universe changed. It's like, there's not just one galaxy, there are billions of galaxies.
As there are billions of phones.
Billions of phones. Yeah, I wonder how many of those are in use.
Thanks so much, Todd.
Thanks. Bye.
All right. Hey, thanks everyone for stopping by for Show and Tell. It was great to see you and your projects. And in some of the chats, people are asking about links and things. So if you're able to head over to the Adafruit Discord and look for the live broadcast chat channel, you can drop links in there if you have projects to share. And now we're going to take like a 1-minute break, and I'll be back with the John Parks workshop that's happening in the Ask an Engineer time slot. So I'm going to go and sip some water. I'll see you in a little bit. Thanks, everyone.